Welcome to Advanced Java Programming at Portland State University. In this screencast, we conclude our discussion of the reflection API in Java. I'm talking about the meta class, working with fields and methods, and then finishing off with a discussion of resource files. Okay, so class loaders not only load classes into the JVM, but they also create an instance of a class, JavaLang class, that represents the class itself. This is the part of the lecture where I say class about once every third words, so if you're playing the Advanced Java drinking game at home, please take a shot every time I say class. You're going to make it about another 35 seconds. Okay, so this JavaLang class, or the class, is something called the meta class. So this is an object that represents a class itself. And we've seen this before. When we talked about JavaLang objects, we talked about all of the methods that are provided by JavaLang object. One of them was called getClass. So this is for any object. You can get an instance of the class that represents the class of that object. And so if you look at what the class provides, it's information such as the name of the class, what package is the class in, is that class an array class, is it an interface, what's the class's superclass, things like that. And then you can also perform operations on the class, like, okay, I've got a reference to this class, create me a new instance of it. And you can call new instance with 0 arguments, which will invoke the 0 argument constructor, or you can provide arguments to the new instance method that will then be passed to the appropriate constructor of the class. So what the meta class allows you to do is introspect a class at runtime. Now in the language, you can access the capital C meta class of a class using the following notation. So if I say something like string.class inside my source code, that returns a class for that represents JavaLang string. Similarly for integer, and then also there's one for int. So this is interesting. There is a meta class for the primitive type int, and you need this so that you can, well, that when you, so for instance, let's say that you have a method that returns an int, or a class that has a field of type int. When you use the reflection API and you use this JavaLang class API to find out about that field, and you ask, hey, what is the type of that field? You need a class, you need an object that represents, you need something that represents little I int. So naturally, the class for little I int does not have constructors or fields or anything like that, but that's okay. It just means that when you ask the class for little I int for its array of methods, it just returns an empty array. Okay, here's another example. Oh, here's an example of using the meta class. What this program does is really quite simple. There's one argument to the program, and what it does is it loads the class and creates a new instance of it using the 0 argument constructor. So you give the program the name of a class, it will instantiate it and print it out. How does it do that? Well, first we need to get a class loader so that we can load the class. So we're going to use the system class loader, which means that we will look for classes on the class path, the JVM's class path. Then we will load the class that's named by argument 0. That gives us an instance of the class. Then we're going to call its new instance method, which returns some object, and then we're going to print it out. So we're going to invoke the toString method of that object and print it out. Several things can go wrong in this program. Maybe we can't instantiate it, like an error occurs while invoking the 0 argument constructor, or maybe the class doesn't have a 0 argument constructor. We'll get an instantiation exception. If the constructor isn't public, then we'll get an illegal access exception. And again, if we give it a class that doesn't exist, we'll get a class not found exception. So let's run this class. And let's, okay, Java util date. So we give it the name of a class on the command line. It loads that class using the system class loader and prints out the toString of that instance. Loads the class, instantiates it, and then prints out the toString of that of the instantiated object. Let's say array list. It prints out an empty array. Similarly for hash map. Empty hash map. Let's say we have a class that doesn't exist. because I can't find it. And maybe we have a class like human that has a constructor that requires one argument. It throws the exception, the instantiation exception, saying that it can't be instantiated because, well, human doesn't have a zero argument constructor. So anyway, I hope you're getting a feel for this sort of this meta nature of this, right? The source code of instantiate class doesn't know what class it's dealing with. It just takes some string from the command line. So it doesn't know that it's working with a Java util date, or it doesn't know that it's working with your human class. It doesn't care. So this is more than just programming to the interface. This is like programming to the bare bones of just these abstractions over classes and objects, and as we'll see in a minute, methods and fields. So the meta class, the class, has a couple of methods for class loading. So instead of getting the class loader directly and calling load class from that, you can also use the forName method, which is a static method of the class that can be used to load a class. You just give it its name and it'll load it. Now there's a Boolean argument to forName. So forName is overloaded to take a string, a Boolean, a couple other things I think, that determines whether or not the class is initialized. So what class initialization does is it sets the initial values of the class's static fields. It's kind of like a constructor in that way. We think of it as a constructor for the class. This is what's called to initialize the class as opposed to a constructor which initializes an instance of a class. There's a special language syntax for initializing static fields. Of course, you can just assign the value in the field's declaration, but if you need to do something like invoke some methods or whatever, you can have something called a static initializer, which is a code block that starts with the word that's prefixed by the word static. Okay, so the class model is a class, and there are also classes called M method and F field in the reflection package, which model, well, methods and fields of a class. And you can get at these objects using the get field and get method from the class. So the whole idea is that you get the class, the meta class that represents the class for an object, and then you can interrogate it. You can ask questions about itself, such as hey, where are the fields, where are the methods, and we also saw earlier that there was methods for getting the name of the class, the package that it's in, what its superclass is, and stuff like that. There are two flavors of getters for fields and methods. There is just get field and get method, which are kind of convenience methods in that if it doesn't find a field by that name, it'll look for it in superclasses. If you only want to find methods or fields that are declared on that class, there's get declared field and get declared method, and so this will let you return any method or field, whether it be public, protected, it doesn't matter what its visibility is. Constructors are also represented by their own object, and you can ask for these constructors, and it takes an argument. Sorry, it takes the get constructor method takes an array of classes that represent the parameter types for that constructor. And of course, while you're doing all of this, if there are things that go wrong, such as you ask for a field that doesn't exist, exceptions like class not found exception, no such field exception, and no such method exception will be thrown. Field has methods that let you determine what its name is, what type of field it is, its accessibility level. And then if you have an instance of the class, so you just have a plain old object lying around, you can use the field object to get the value or set the value of the field. And so then this allows you to work with the object not as its particular type, but as just any old object, and here's the capital field that I can use to get and set the value. Similarly, a method can be invoked on a given object with some parameters. And note that the type of that you send an array of objects to a method invocation, and so then if you have a method that takes a primitive type, you need to send in an instance of one of the wrapper classes or use autoboxing. So there's a class called describe class that I wrote. I won't look at the source code, but let's look at the output to see the kinds of things that can be gleaned using reflection. reflect describe class. And let's choose something like an interface, like Java util map. Okay, so what I did here is I entered the name of a class, and then I used the reflection API to load that class. And then I've interrogated the class. I've asked it, okay, tell me about all of your methods, all of your fields, and things like that. So as you can see, we have an interface that's abstract and public, and here we have all of the methods. And for every method, we print out, well, its accessibility, whether or not it's abstract, its return type, its name, and its parameter types. Okay, let's look at at a real class. Let's look at an array list. Oops. Okay, here we have a class array list. Through reflection, you can find out what its superclass is, all of the interfaces it implements, and information about its fields and methods. So ArrayList has a static field called serial version UID. It has a private field. Transient means it's not serialized, kind of beyond the scope of this discussion. The array syntax, so we have a field called element data, and the type of it is an array of object. And this is the syntax that's used. This is an array of objects. You got a size, constant for max array size, and here you've got all of its methods. So you can get all of this information using the reflection API. And as you can see, there's some stuff that you may not expect. There's like this, I don't know, this access $100 method. No idea what that does. Access $200. So remember, this is coming from the class files, not from the source code. So the Java compiler, Java C, may add some extra stuff. Looks like it adds methods that aren't there in the source code. And I know it's not in the source code because in Java source I can't have a $sign in the middle of a method name. So you know when you see something with a dollar in it, it's very, very, very likely generated in a huge capacity. So you can get insight into what all of the private fields and private methods are. Okay, well, that's kind of neat. Okay, why is this interesting? Why are we covering it? Well, first of all, it's one of the more advanced features of the Java programming language. I couldn't justify calling this course Advanced Java Programming. As we talked about some of these things that maybe you don't see every day, but things that you ought to know about to understand how the Java platform works. Reflection is interesting because it allows code to be dynamically loaded into a JVM. So unlike, well, I mean, you think about your traditional, Fortran program where everything, big monolithic code base, big monolithic executable. Java is way more dynamic. And so code isn't loaded into the VM. It doesn't take up memory. It doesn't do its thing until it's actually needed. So it's sort of like last possible moment that stuff is loaded into the VM. But I think most importantly, reflection gives us this sort of meta API on top of the Java programming language, on top of Java objects. So it allows you to manipulate objects without having to know the object's type. And so then, like I said, this is beyond programming to the interface. This is like programming to just objects with classes and fields and methods. And it allows you to have a very loose contract between objects that are being accessed in the code that's accessing the objects. And this forms the foundation for what are called software components. The whole idea is that you have all this convention between the objects being worked with and then the code that's working with the objects. And so reflection is used in a number of places in Java. There's something called serialization, which is an API that takes pretty much any old object and turns it into a stream of bytes. It basically goes through the object and encodes the object as bytes. And you can imagine that reflection is used then to interrogate the object to figure out what its field values are, what its name is and stuff, and writes it out to an output stream in a certain format. And then when you go and read what was written to that output stream using an input stream, it'll reconstitute objects. You can also use reflection to dynamically generate code at runtime, sort of on the fly. And tests are also run reflectively using a test harness. And so when you think about what JUnit does, when you tell the JUnit test runner to go off and run the tests in a given class, it uses reflection to figure out what needs to be run. I suppose I don't really talk about it here in this lecture notes, but there are other parts of the reflection API that allow you to figure out what annotations there are on a method. So you can imagine the algorithm that the JUnit test runner goes through is given either the name of a class or maybe a Java class instance that says, okay, here is a test that you need to run. And it uses the reflection API to say, okay, go through all of the methods. And if a method is annotated with that @test annotation, hey, that is a test method. I will run it, and if it throws any exceptions, I will catch them and process them and things like that. And so, here again, the JUnit framework doesn't know anything about your classes. It doesn't beforehand. The framework itself doesn't know the name. All it knows is that there is this convention that you follow, that you slap this @test annotation on a method that you want to be a test, and the JUnit framework says, okay, that is the deal that the framework, between the framework and the test author, and it all goes from there. So reflection really allows you to work with your classes at a very high level and have sort of extreme decoupling between something like a framework or a test harness and then the code being tested. There's one other part of the Java APIs called resources that's implemented using reflection that I want to go into in some detail. I think it's another good example of how class loading can be used. Actually, in this case, it's not to load classes as much as it is to find these so-called resource files. As your program grows and does more things, gets more complex, you want to separate out resources that are used by the program from the program source code itself. So, for instance, messages that are issued by your program, right? Help text or whatever. By now you've probably figured out that it's kind of awkward writing big pieces of text in Java source code, and that's fine because we probably should be keeping big pieces of text out of the source code and in someplace else. You can use a resource to store these. Also, things that can't be encoded, or at least not easily encoded, inside source code, things like images and sound files. So there's this API that's available for obtaining resources that are independent from the code that executes them. So they're not part of the source code. Instead, they're referenced by the source code and then used in some way. A resource, it's a lot like a class because it's actually implemented using the same underlying mechanism. Resource is identified by a name, and there are slashes between parts of the name, and there is an extension, so something like .text or .properties. Now, resources usually mirror the package that they're related to. So you can imagine if there were error messages for some of my code, it would be in a package called it would be in a resource named edu/pdx/cs410j/error_messages.txt. And resources may reside really any place a class can, on the file system, in a jar file, in a database, and some other object. There's a nice abstraction over the source of the resource. So class loaders can be used to obtain resources. And so a so-called system resource is like a system class. It's loaded by the system class loader, and they're sort of built into the Java runtime. And you get at these guys using the getSystemResource method of classLoader. And so it returns a URL. And then you can read from that URL, you can do whatever. And because it's loaded by the system class loader, it'll look on every entry on the class path. If the resource can't be found, then null is returned, so you know that it isn't there. Now there are other class loaders that provide their own ways of getting resources. So for instance, there's the applet class loader. So if you're using an applet, like if it's 1998, you can call the getResource method. There's also a getResource method on the meta class, on JavaLang class, that will look for a resource relative to the class's package name. And so what this allows you to do is to locate a resource without having to hard code in the path to the resource into the source code. You can just get a class and say, hey, find me a resource which is in the same package. Note that if you begin the name of the resource with a slash, then it's sort of like an absolute file path in in Unix. And so then the get resource method will ignore will not look for the package name. Not only can you get resources as URLs, but you can also get them as streams using methods like get resources stream and get system resources stream. Okay, here's an example of using resources. So I have a program that prints out the Declaration of Independence to standard output. And I don't want to put the entire contents of the Declaration of Independence into my source code. I just want to have it there as a text file. So I put my my text of the Declaration of Independence in a file called DOI for Declaration of Independence, not for DOI, but anyway. And I put it in a place, it may even actually has a standard location for resource files. Instead of source main Java, it's source main resources, or it's resource, I can't remember off the top of my head. And if you put it in that directory, Maven will add it to the jar file it's built right next to the class files, and so that the class loader will be able to find it. So it ends up in a place like edu/pdx/cs410j/reflect/doi.txt. This program here, print declaration, will basically get the resource and print it out. So the first thing I do is, this is just for an example. I show what the absolute name of the resource file is, and I'm going to use the get resource method from class. I'm going to get the reference to the meta class for the print declaration class by saying print declaration.class. I'm going to call the get resource method with that absolute name. I'm going to get a URL, and I want to print out that URL so that we can see what a URL for a file that's part of a jar file looks like. I'm going to then obtain that same resource in a different way. I'm going to call get resource as stream. From here again, relative to the class, I'm going to use the relative name of the resource, so it won't look in the it'll look for doi.txt relative to the print declaration class. Okay, that just gives me an input stream. I want to read input stream one line at a time. So here again, I got to create an input stream reader around the input stream, a buffered reader around that. Now I've got read line, and I'll print that out. If anything goes wrong, I'll print the stack trace. Let's take a look at running that program. And here we are. So note the first thing that we print out is the URL of the location, or sorry, of the resource, and it's because it's loading it from the class path. Let's go back to the command line here. It's loading it from the file path, rather from the file system directly. It's just a regular old file URL. But let's say I ran it using the, or rather I loaded it from the jar file. Now I get a slightly different looking URL. So the protocol for the URL is jar:\file, and the file is the following. First is the name of the jar file, and it's got this bang, and then the entry within that jar file. I think this is kind of interesting how Java represents an entry into the jar file, but I guess it just sort of shows that there's this really nice abstraction over where you get these resources from, right? My source code doesn't know that the Declaration of Independence file comes from the file system directly or from a jar file. Who cares? Let the details of the class loader and everything like that take care of it. It just knows to ask for it. When it finds it, it returns an input stream and then reads the entire contents of the Declaration of Independence from that input stream. Again, there's kind of a funky URL, and you can then find out if you really wanted to, based on the URL, where that resource file came from. So this resource API forms the foundation of the localization capabilities in Java. So the whole idea is that there are variations on these APIs that will get a resource for the current locale. Right? Remember when we learned about date formatting, we saw a couple of examples how dates and times would be formatted differently depending on the locale in which the program was running. And here again, a locale is a country language combination, country spoken language combination. Well, there is a object, a class called locale that represents varying locales. And what you can do is you can have different resource files for different locales. And I think basically what you do is you append the name of append an underbar, like underbar en for underbar English, or underbar es for Spanish, things like that, for different translations of your resource files. Anyway, I won't go into too much detail there, but if you want to find out about these things, you can look up classes like locale, resource bundle, and formatter that are all part of the standard Java API. Okay, so in summary, what's Java Reflection all about? Well, the Reflection API allows programs to inspect objects in their classes. Here again, at a very abstract, sort of a very meta level. We learned about the class loader, which is responsible for loading class files, as we saw with resources, really any file, from some location. Class loaders know how to take class files, the Java compiled bytecode, and create these class objects from them. And so, well, loads it into the VM also, and so it's the thing that takes the bytecode instructions and turns them into machine instructions, all that good stuff. But what you can get from your source code from class loaders is are instances of these meta classes. So classes are most often loaded implicitly, but they can also be loaded explicitly, like for instance to run a JUnit test or something. So this Reflection API really provides meta access to information about your objects. So you have classes that model fields and methods of a class, and you can get all sorts of information about their name, what their accessibility is, and then you can work with fields and methods. You can use the capital F field object to then get or set the value of a field in another object. You can use capital M method to invoke methods. And finally, class loader is the mechanism that's used to locate external program resources. So things like images or sound files that are part of your application, or text messages that can be localized. Well, that's all for now. Thanks for watching the Advanced Java Programming screencast at Portland State University.